Good afternoon and welcome to Back to Business, the AI edition. We need to talk about the name, right? Back to Business. So when we first thought about creating this event, we thought about, okay, we're going to bring everyone together because we're back to work and we're ready to network. Well, things change. But if there's one thing we learned in Corona times is how to do events online. And you are joining us. So thank you for watching. And we're going to start because we're excited. Please join me on stage, Paul van Son. Paul is the Innovation Manager of the High Tech Campus and also the initiator of the AI Innovation Center. We're doing this event together. Back to Business, the first edition. This time it's dedicated to AI in business. Paul, the Innovation Center for AI was launched this spring. How's it going?
Well, it has been quite an exciting past few months. So we started in April with also a very big hybrid event, something like a similar setting like today. Also with one of the same speakers, Arnaud was also there. It has been quite exciting actually to start such a big initiative in a time of COVID. But yeah, actually, it's quite successful so far. Maybe to give a little recap of what we've been doing.
Yeah, please.
So we've held a few events, hosted the first education, some workshops, and already also 12 companies are located physically in the center. Of course, they're now working from home again. But yeah, so far it's going very well.
That's good to hear. And the goal of the center is to industrialize AI in the Brainport region. How are you going to do that with the center?
Yeah, of course, this is a very big ambition, right? So we have to collaborate for this. That's the only way that we're going to achieve this. So we work together with other entities in the Brainport region, also with the university, but also with University of Tilburg and Den Bosch, in the so-called AI Hub Brainport, part of the Dutch AI Coalition. But also we, as AI Innovation Center, we really want to focus on the applied part of AI. And I think today we're going to give a good insight in some of the projects and initiatives that are already ongoing. And what we are going to do also this year still and next year is really scale up events where we take companies by the hand, show them use cases in their industry, and make them really take the next step towards AI adoption.
Because it's about talent also, right?
Talent is of course one of the most important things, and therefore the content we program is really key, of course, in the center. And with creating also this physical center, really vibrant center in the middle of the campus, we also want to contribute to putting this region and the campus really on the stage when it comes to AI talent.
And you already said about scaling a bit up. Is that also in the space?
Yeah, of course. So we, as mentioned, we have already 12 companies located in the center. We're doubling in size next year, so a lot of opportunities there to also welcome new AI companies on campus. But it's not only on space, right? So we really want to scale up on the content that's going on in the center. So we're going to co-organize together with Brainport Development, for example, sessions in certain industry verticals. In 4 sessions, we really help companies from the awareness phase of what can I do with AI in my space, in my industry, towards really adopting it in their day-to-day business and in our products and services. So that's one of the things we're doing. We're also planning for a very big AI conference in spring. Okay. So all kind of wild ideas.
The 1-year anniversary.
Yeah, of course. So
yeah.
That's something that you have to celebrate, I think. But we really want to scale up our impact in the next year. So that's a central theme for the coming year.
So thank you for telling us, and we're going to enjoy today. Thank you for being on stage.
Thank you.
So we're going to go to our first keynote speaker. He's from a startup which is growing really fast, accelerating AI at the edge. Give a big virtual applause to Fabrizio Del Maffeo, CEO and co-founder of Accelera AI.
Thank you very much for having me here today. Very excited to be here, very excited to be part of the AI Innovation Center. And I want to tell you our story. Yes, I'm a co-founder and CEO of Accelera AI. And over the last 20 years, I've been working in computing, in Internet of Things, artificial intelligence. And here you can see some of the products where I work on. in my past experience in Advantech, in ASOS Group. One of the most important experience was the experience with App Bridge the Gap, which is a brand that we have launched in 2015 in Kickstarter, and eventually became the reference design for Intel for Internet of Things. And during that experience, I started to look carefully inside artificial intelligence and wondering if it was possible to bring to market something specific for artificial intelligence for business to business. And we teamed up with Intel and launched in 2018 the AI in production, taking Movidius, which was the first AI chip for edge application, and integrating it inside the products and bringing them to market for companies who were willing to integrate the AI in their solution. Then I fell in love with AI, and in 2019 I joined Bitfury Group, which is a deep tech Dutch group, and we started the artificial intelligence division, and we eventually teamed up with IMEC. And together this year we spun off the company a few months ago and launched Accelera AI. In Accelera, we are developing a powerful, efficient, competitive, and user-friendly AI software and hardware platform, which aim to accelerate the computing vision at the edge. Although the company is very young, we exist for less than 6 months, we have on board 32 people, 23 PhDs, postdoc, from large corporation, from university. We are going to have other 10 people join us early next year. And we have the headquarters here in Eindhoven with offices in Leuven, Zurich. We are looking for talents. Then if you want to join us, please apply. We have more than 30 vacancies. We plan to scale up to 100 people by the end of next year, and to deploy in coming years, and also raise in coming years, 100 million, and having to reach 250 people and profitability. Among our investors, there are Bitfury, of course, Innovation Industries, a Dutch VC, IMEC Expand, Belgian VC, and IMEC Group. And here you can see also Evangelos Eleftheriou, which was the former leader of the neuromorphic computing activities in IBM, joined us as co-founder and CTO. Then we have a very strong team. And in this picture, you see the chip taped out by our team. Then among the people in our teams, there are guys that taped out the first analog AI chip in the market, in-memory computing chip, analog and digital, but also people that contribute to products that you can, that they are using now in your laptop, product from Intel. Then we think to have the right expertise to make this plan a reality soon. And if you look at the edge, well, AI is moving at the edge, it's a matter of fact, but you have a lot of constraints. I think there are people here that are going to present later some problems that you may see at the edge. Limited power budget, limited computational power, limited connectivity. It's also difficult to scale the computational power at the edge, not like in the cloud where you can just rent servers or computational power. And you have also constraints, environmental constraints. You have to cope with extended temperature range, fanless operation, humidity. It's clearly that you cannot take the architecture you have in the cloud and drop it to the edge. It doesn't work. It doesn't work at all. It's not possible. But the real problem is this, is if you look at the AI, which is today developed in the cloud and where you have unlimited computing power, almost unlimited, I would say. Actually, you see the trend of neural network. They are, if you look at image processing models, they are doubling the size year after year. But if you look at the language processing model, they are increasing 20x year after year. I mean, the trend is outrageous in terms of resources needed to fulfill the requirement. Then it's unsustainable without a significant hardware and software innovation. We have to do something. And when you look inside this neural network, you see that actually 70 to 90% of the calculations are simple matrix vector multiplications. Then you are multiplying numbers, huge tables of numbers. But actually, today computing, the standard computing, is not optimized for this. It's not meant to do this calculation, to parallelize so much the computations. Today, computing is still based on the von Neumann architecture, where you have a processor, you have a memory, and you move data from memory to processor, you make the computation, and you go back to the memory. And this clearly limits the parallelization of the computation, but also, as a side effect, generates a lot of power consumption. Actually, the power consumption in a chip is dominated by the data movement, and you can see here that moving data from LPDDR has a power consumption which is 2 orders of magnitude higher than the multiplication of the data, the calculation. Then what we are doing is bringing to market a game-changing technology, which is in-memory computing technology, and we are putting it together with a data flow architecture. The in-memory computing technology allows to take a memory cell, modify the cell, to compute inside the cell. Then you can imagine you have millions of cells, and in one computing cycle, you can make millions of computations. Then you have very high parallelization. And we are putting this technology together with the data flow technology, which allow to be flexible, because the neural networks are different. There are plenty of topologies. And then combining the two, these two technology, we can have an hardware which is very efficient, very powerful, highly programmable, and we think perfect to be deployed at the edge, but also to scale up in the cloud. We decided to focus on computing vision, because one image is worth 1,000 words, they say. And when you solve computing vision, when you solve the problem, actually, you can apply it to several markets, right? You can see computing vision in retail, in security, in drones, in manufacturing. Essentially, when you optimize your hardware and software platform to run efficiently specific network, the data make the difference. But you can then apply it to multiple markets. But what we do is then not only developing the technology and integrate the technology inside the chip, but we want to enable all the supply chain to deliver to customer products that can be deployed on the field. We have deep expertise to do so, but also be sure that our technology can support standard framework, because it's clearly that today people, software developers, they are not willing to learn different software tools for different hardware solutions. Then we are working hard to make our technology fully compatible with PyTorch and TensorFlow. In a nutshell, what we are doing is to create a platform which allows customers to buy the specific hardware for field deployment, get it very quickly, download the software package, and use it together with the standard framework like PyTorch, TensorFlow, and then go to our community where they can find optimized neural network, but potentially, in our vision, they can sell back their product. They can provide solution to end users. And we want also to enable our technology to be compatible to existing ecosystems in robotics, in makers, in drones. We think that it's extremely important to deliver to market something that is almost plug and play. It's something that is missing out there. There are good hardware solutions, good software solutions, but it's still missing this part to have efficient, powerful, cost-effective plug and play technology. And why we want to do this is because we believe that there is a huge potential out there. If you look at today's situation, there is scarcity of resources. There are probably 25, 30 million of software developers, but how many of these software developers, how many of you, maybe some of the people that are listening to this presentation are software developers, how many of you have a really deep understanding of how the neural network works, what's happening inside the network? It's clearly that it's necessary to democratize this, to give a platform which can be used by normal software developers, people that just want to add AI to their solution without changing the shape of the hardware, without changing the software stack, without redesigning from scratch everything. And these people that are typically small and medium enterprises represent 99% of European firms, represent 95% of global firms, and they cannot afford to get highly skilled deep learning engineers. Only big corporations can afford. Then we think that our technology can help this company to introduce AI in all of their products for the edge and later in the cloud, and scale up quickly. Where we are today is shown here in this chart. We test and tapped out already before, during the incubation period, several chips. Now we are ready to test and tape out almost the final chip for the internal validation. And next year, we are going to deliver the sample to customers, the first sample to selected company. We are going to open our technology in 2023 to give open access to everybody, and to open also our community, our shop, and allow customers to just go online like you're doing today and buy our hardware, go to our community, play around. And I hope that you saw something interesting in my presentation, and I hope also that you will reach us out, maybe because you want to reach us and become part of Accelera team, or maybe because you want to adopt our technology. Then thank you so much.
Thank you, Fabrizio, and please stay on stage. So if you have a question for Fabrizio, please ask them in the YouTube chat. So we're reading them right here. Somebody already wrote, how did it, I don't know about Accelera. I mean, they're so curious about your company.
Yeah, as I said, we just started. We are pretty new, just born.
Yeah.
We were born only 5 months ago. Then, and we stayed in stealth mode until September, middle of September. Now we are working to grow the team, to hire more and more people. We need talented people. We think that Europe needs a company like us who wants to deliver cutting-edge technology, take the risk to deliver the best technology to the market. And we are going to unveil more and more information in coming months when we are going to unveil the product, actually.
That's exciting. And you already spoke about talent. How hard is it for you to find talent?
It's extremely hard on one side to convince experienced people in their late 40s, 50s, close to my age, I would say, to join us because they are risk adverse. European people are risk adverse. But when we pitch and we talk to young people, PhDs, they are completely excited because they study, they produce papers, they want to do something, have an impact on the society, and they don't find the European company willing to take this risk. And then they end up to work only with American company, which is not a bad thing, by the way, but still they love the idea to be part of a truly European startup who wants to change the AI, make a large impact in the AI market. And
why here? Why the Brainport region?
Why here? It's the heart of Europe. It's the heart of semiconductor in Europe. I mean, there is NXP, ASML. I mean, this is the...
It was a no-brainer.
Yeah? It was no-brainer. There is Belgium with IMEC is close by. It was really no-brainer. Of course, we had also opened offices in Zurich because you have the ATH, you have expertise. We cannot limit ourselves to this region because, unfortunately, we need the best people in Europe, but still is the place to start.
Okay. And what if someone is watching and thinking, okay, how can I make sure my company grows as fast as yours? What would
well,
you say?
it's easy. We are growing in people because we collect money that we are spending to other people. Then,
Okay, so money is the
I
key.
think money is the key is find a way to raise the money. Then it's easy to spend money. It's easier to spend than to raise, I would say.
Okay.
And it's a big challenge still to raise, especially if you have an ambitious plan like we have. When you pitch 100 million plans, investor in Europe, they get scared.
What is your giveaway to do that?
Yeah.
How do you do that?
Yeah, I think that you don't have to give up. You have to just to accept all the knowledge you're going to get. Probably 95% of people will say, "Forget it, you are crazy." Staying calm, move on, assess your plan, put together a very strong team. Even on paper, I mean, convince strong people to join us because it's not a one-man show. I mean, this company is not my show. I have a very talented team on board, and they make the difference, actually, not me. And they helped to make it happen, actually.
How do we get in touch with you? Someone is asking.
Just write to me, Fabrizio.Del Maffeo, name.surname, @Accelera.ai. We are very open communication. Just reach me out or reach out info@Accelera.ai. I'm willing to talk to everybody.
Okay. Well, thank you for joining us.
Thank you so much.
Thank you so much.
Thank you for inviting me.
Of course.
Bye-bye.
So, let's move on to our second speaker of the day. He is a true AI trailblazer and works for ASML as a product cluster manager. Give a big round of virtual applause to Arnaud Hubaux. Please join me on stage. Welcome.
Thank you for having me.
How does it feel to be here in an empty auditorium?
It's fantastic.
but people would be more nice, right?
Exactly, of course. We love people.
Definitely. So this talk is a conversation between the two of us, but if you have questions at home, please ask them, write them down in the chat, and we'll include them in the conversation. So adopting AI in your business strategy requires more than technology. That is the topic you wanted to talk about.
Yes.
Why? Is that something people don't realize?
Yes. So actually, some weeks ago, someone from my team came to me and told me, Arnaud, I'm going to leave ASML. And that person is a brilliant data scientist. We worked a lot together. We went to customers together. We ate some strange food in Korea together, like live octopus. We filmed multiple times together. We got back up together. We even got the customer award for it. And there he was telling me in front of his webcam, Arnaud, I'm going to leave. And that hurt me a lot. And of course, I didn't want him to go. But at the same time, I was trying to understand, but where is it coming from? And what I realized is that what he wanted, I couldn't provide to him because he wanted to work on very big data streams, apply the latest text in machine learning on it, and we don't have those big data streams. We don't get them as an equipment vendor. So actually what he needed to be happy, I just couldn't give him. So I decided, well, then go, and I hope you're happy with your next venture. And it really made me realize two things. So first, in the AI world, there are many, many different tasks behind ML engineering or AI engineering. And it is very important as an engineer that you know what you want to do. And then as a leader, it's equally important to understand what you want or what you expect from the engineers and communicate it as clearly as possible.
Yeah, because in the work, if we look at the data scientists, the data engineers, machine learning engineers, so they don't have all the data, but you still have to make a good, functional product. But how hard is that?
It is very hard, because typically you come with all the knowledge you learn from books, from tutorials, from university, and you apply it, and it doesn't work. It's not that those technologies don't work, it's just on the data we have, it doesn't work. So you push harder, you do all the tricks in the book, and still it doesn't work. So there you have two choices. Either you just drop the ball and leave, or you look at different ways of still making it work. And the way we do it is, if you don't have a lot of data, you have to spend a lot of time in understanding the input of the model. Because if you build features extremely well, you need less data to be accurate. So it means that your work becomes a lot more jumping down the rabbit holes and understanding the physics of the machine, how it works. Spend a lot of time on building better features that will give you the accuracy you need. This is one. And secondly, you also need to make sure your model is learning by itself. Traditionally, an ML engineer will have an ML ops pipeline, and they will look at it, they will measure it, they will start the retraining. In our case, no. You have to make sure that your solution can learn by itself.
But then you'll never see it work.
Correct. You'll never see it work. Only you hear when it doesn't work. That you do.
But how do you deal with that? As a data scientist, as an engineer?
It is difficult. So first, from a personal perspective, sometimes I have the engineers who tell me it almost feels like I gave birth to a child and I have to give my child at birth and someone will take care of him, I know. It will be well taken care of, but I will never see it work. So this is difficult. But at the same time, what I find interesting is that those people really find joy in building the upfront physical models that are then deployed. And then at some point, the machine learning part becomes less important. What becomes more important is the upstream investment they put into the physics.
So the role is really different than, for example, in a company like Google.
Yes, Google or Amazon or Facebook, those companies, they have huge data streams coming their way. We don't have this. So we have to make it up in our ability to engineer those features and really deeply understanding the system.
But how come this is so unknown, that working with AI in a company like ASML is so different than in, for example, Google?
Because if you look at all the hype and all the buzz, it's around big data and tons and plenty of images. And actually, if you look at the manufacturing or equipment world, you don't really have those. It's not too much advertised. And also, you see that the industry in general is still not fully adopting AI, because there is no full understanding of, is it trustworthy? So this is where you see that for companies like Facebook, if they fail recommending your product, no one notices. If Amazon makes a mistake in recommending a book, no one notices. If an AI in the semiconductor industry makes a mistake, it costs you millions.
Yeah.
So this is why we are a lot more careful making small steps to prove that we are reliable.
And how do you deal with this in a company, for example? How do you deal with the fact, you said it was all about trust, right? Because a small mistake can be way bigger in a company like ASML. How do you deal with that? So
it's about trust inside the company, but also with our customers. So it's about showing the weaknesses up front, and discuss those weaknesses, customer by customer, customer side by customer side, because the chips they are making are so specific that there is no ground truth. Every case is almost unique. So we really need to build the trust in the models, show the weaknesses, and always do it in 3 steps. First, prove it is accurate, then prove you can explain it, and then prove you can sustain it. If you fail any of those steps, you're done.
You have to build the trust. Are customers open to talk about that?
Yes, they are very open about it. And it reminds me of this quote from Joe Claassen. He said, "The truth will set you free, but first it will piss you off." It's always like this. We always have tough meetings with customers because there is no sugarcoating, there is no sweet talking. It's only engineers looking at facts and making decisions together. And they are very open because everyone is actually searching for how to get value out of AI in a sustainable way. It's very easy to have a lucky shot and perform well, and then this is it, but this is not how you build an industry worth billions. So you really need to have reliable models in place.
And if we go back at the talents, at the engineers and the data scientists who are doing this job, their role is really different. How do you challenge them as a leader to stay? How do you deal with it as a leader?
Yeah.
How do you retain talent?
So, well, the first thing, I think it's important for engineers to know what they want, but it's also important as a leader to tell them what they will do. Otherwise, there is nothing worse, at least for me, to hire someone and ask then him to do or her something else than what he was hired for. The second thing that is very important for me is look at the soft side of the work they will have to do. So look at the soft skills they need to have. Just to give you an example, I had an engineer in my team, data scientist, brilliant guy. At some point, I asked him, please come to me because I need you to explain the results to a customer. So he did it, and he said, I hated it. I don't want to do it ever again. I was like, why? It's part of the job. I mean, you do it to solve their problems. You don't do it to have your fun. I mean, you need to have fun, but eventually it has to have business value. And he told me, I don't want to do it anymore, and then he left. So I replaced him by someone else with the exact same hard skills. And that person came to me after having done another customer presentation, and he told me, I love it. I never knew as a data scientist I would have to talk directly to a customer. I love it. This is so great. So this is where your role as a leader to also bring that aspect forward when you are hiring someone or offering a job. So for me, it's not the retention. First, I hate the name retention. It sounds horrible. It's like you're locking people in the cage.
Like they're in a prison. Yeah.
Exactly.
Yeah.
Just don't
they
go
have
there.
free will, of
exactly.
course. Yes.
Yeah. So I'd rather give them all the intentions to stay, and if they want to go because they don't feel happy, just go. Be my guest, please. So it means that if I want them to invest in the company, I need to invest in their future as well. So it means that I need, when I hire someone, to know where he or she wants to be in 5 years from now. Maybe it will change, but at least the moment she or he starts working, we already work towards that dream they have, by coaching, by mentoring, by training. And this is very important to make sure that you invest in the future today. And another aspect that is important for me, especially in large companies where people are exploring about AI, we don't really know how to get the value out of it. So we are experimenting a lot, and we are defining different kinds of business models together with our customers to figure out what works and what doesn't work. And sometimes it doesn't work, and it's very easy to just throw the data science team under the bus because you guys didn't perform. No, it has nothing to do with the performance of the team. It has to do with maybe the business model was wrong. Maybe the assumptions we had were wrong. Maybe we expected AI to solve all the issues in the world, but it doesn't. So it's your role as a leader to be able to protect your team from that kind of very bad vibe. And also upfront, try to prevent it by when people come with ideas for new business models, you explain to them, guys, we need to be realistic. Nice idea, but maybe we need smaller steps, or we need to make it sure that it's something we can achieve within a reasonable time frame.
And how do you challenge your talents? Because they might be wanted to work, for example, at a company like Facebook. They have a lot of data stream. They don't have it with ASML. Yep. So how do you challenge them to make sure they really like their job?
It's a good question. Well, I think it's explaining to them that you will have a miserable life for a while, but it's worth it. Meaning,
why?
Because so if you work in a big company with a massive amount of data, simple things like extrapolations are very easy because you know that in the bag of data you have pretty much all the points in the population, so those kind of things are trivial. You know, machine learning will pick it up quickly. Might take you hours of training, but it will pick it up. In our case, you know it will fail. So be creative, because this will fail, so find something else. And what is trivial when you have a lot of data becomes very difficult for us. So it means that actually they have to go where very few people go. And it can be very rewarding because they get to be very creative by applying the technologies that everyone knows pretty much how to use. They have to bend and shape them in a way that works in a context where they were not designed to work. So this is, from an engineering perspective, extremely challenging.
A nice challenge.
Very nice challenge.
What do your colleagues say about that?
They hate me when we start, and then they love it when we end, because it's really a journey for everyone. And this is why I mentioned talking to customers, because this is not something we can do in splendid isolation. We are searching, and we have to do small use cases after small use cases. So at the end of the day, if you look at a project of 1 or 2 years, everyone grew tremendously in all aspects. So the domain experts learned a lot about machine learning and data science. The data scientists learned a lot about domain expertise. And they also learned a lot about how the industry is working, about how you make chips from a real-life perspective, not nice on papers, but really the hurdles of manufacturing those chips. So, and also their soft skills, as I explained, is developing tremendously because they have to interact with so many people that if you're bad at interacting with people, you don't get anything done. So this is a great learning journey for everyone in the team.
You already said it, you can't do it alone, right? You need the customer, you need to work together. So you work with companies like Samsung and Intel without all their data, right? So you have to be creative, create trust. How hard is it? Is it?
It
easy to talk about it? Because you talk about it, but then what? How do you build the trust?
It is hard and easy at the same time. I think if you show that you genuinely want to understand the problem and are willing to invest time in it, they will come along. And they know it is difficult because everyone is struggling with it. The whole industry is struggling with it. We have to find value together. So if you show that you are working with them and then you give them something, they will give you something back. And this is pretty much this kind of ping-pong game, giving, taking, that eventually results in a solution that works for both parties.
Yeah. And what is your giveaway for companies who want to successfully implement AI? Because this talk was about the talents, how the leaders deal with it, building the trust. It's very different than the talks about, okay, this is the technology and now I work with AI.
Yes. So it's really, for me, start small and dream big. Don't just go full technology on, like brute force, throw data in a model. In a good case, you get some accuracy. In the bad case, you're not accurate. In the worst case, you're accurate, but you can't explain anything. And no one wants to build or buy a solution that you can't explain that is not meaningful. And only people can build meaningful solutions. And building meaningful solutions means that you understand the business, you understand the customers, how it works. And for me, the teams that are most successful are not those with most PhDs around the table. They are the teams who truly want and care about building the right solution for the customers and have fun along the way.
Thank you for this insightful new way also of thinking about working with AI. And one last question for my part. If a company is watching and they think, okay, I really want to make sure that I implement it the right way, can they read more about this topic? Do you know what tips to give them?
I think, unfortunately, at least I don't really find much written on the topic. It's extremely technical, or it's like people being happy that Tesla failed with autonomous driving. It's really more looking back at, I think trust is the essence of AI. It's not accuracy, it's trust in the system, because there is a lot of hype and the trust level is still very low. So understanding what requires people to trust it is the key to deliver the right solution.
So build on that trust.
Yes.
Thank you so much for your time, Arnaud Hubaux.
Sure.
Thank you. Thank you for joining. All right. So we're going to go to our third speaker. She's going to talk about how AI is everywhere, as we know, how embedded machine learning transforms our everyday life. Clara Otero Pérez is Senior Director of System Innovations at NXP. Give her a big virtual applause, please.
Thank you, Ingelou.
You can take a care.
Thank you, everybody. You at home are watching online. Again, unfortunately, I was hoping to be speaking here to a big auditorium. But I'm happy that we can still do it. And thank you to the people listening here as well. It's good to have someone to talk to. So indeed, I would like to talk to you about AI everywhere. I think Fabrizio already mentioned about the edge. Indeed, as NXP, we are also looking at the edge. And I would like to explain to you how we are looking towards the future. So first of all, when we talk about artificial intelligence, what is artificial intelligence? Is that something new? Well, of course, it's not new. The term was coined in the 50s already, when a team of researchers and scientists came together and started to hypothesize, what if we can code every aspect of learning and every aspect of intelligence? Can we get a machine to simulate it? Can we artificially simulate intelligence? Well, from that moment on, a lot of research has been done with ups and downs. And there were two main areas where this artificial intelligence was developed. In one side, we had the expert systems trying to build knowledge, trying to gather all this knowledge. And in the other side, we had another scientist looking at what if we try to simulate the brain? What if we look at the brain like neurons connected, and we try to simulate that and let those systems learn by themselves? Well, those aspects, those two trends developed, and many sub-trends came up, and a lot of research was done. But there was a common theme, which was the compute power required for both getting all the knowledge with all the memory and all the computations of the models of intelligence was very large. And it will take days to get some simulation and get some answer from a machine. The same when we were talking about the more connectionists trying to simulate the human brain with neurons that will fire and that will simulate knowledge or intelligence. The compute power was also very hard. So the AI went through periods of a lot of hype. Hey, we can get a machine that can read text and that can write text. Or, hey, IBM made a machine that is able to beat the big chess player, the master player, and win all the games. But then it also went through periods where people were like, when is this going to happen? When is artificial intelligence going to happen? When am I going to have a robot that thinks for me? And also some people that got a bit scared about what happens if the machine develops intelligence and gets over it. So what has happened in the past 10 years that suddenly AI is everywhere, from being a topic like, well, yes, science fiction, to really like, hey, AI is happening and is really getting to, and we are advancing with AI. And what happened was a combination of 3 factors around, I think, probably 5 years ago. The first factor is we went through an exponential performance growth. So the amount of compute power you have on your mobile phone, actually on your watch, is larger than the big machines that scientists had in the past. So we can do a lot of computation. At the same time, with the generation of the web, the amount of digital content is also growing exponentially. We are talking about 4 terabytes of data being generated. I think we are getting to a point where there is more data being generated than stars in the universe, kind of. This means that a lot of this data is coming from pictures, from sound, from videos, like this video. It will be part of this amount of data being generated. But some of this data is also due to the amount of sensors. So technology has developed in such a way that we can sense, we can feel what's happening around us. So we can know our heart rate just by having a small light being sent to our pulse. We can know whether our phone has fallen with a small impact sensor. So all over the place, we get sensors that are measuring things. And all this data is also being generated. The number 3 that happened and that came together was the coming of some type of neural networks, and that is called deep neural networks with hidden layers, that were able all of the sudden to come up with answers that were far better than all the answers that were done when we were trying to understand and we were trying to model the world. So those networks, self-learning networks or machine learning networks, they came up, and together with the amount of data that was generated and all of the compute power that we could do, that created that, hey, suddenly we are getting a really step in performance. So you can say many algorithms that were really increasing very fast, and they kind of, every year, if you want to get to the next level of performance, you had to put a lot of effort in it. And with this network, you see, you apply them, and suddenly, hey, 15% performance gain, 20%, so amazing. So how is that changing? Let's start with the future. We see 50 billion connected devices by 2025. What does it mean? This means that we are going to have even more devices connected, even more data being generated, even more real world being sensed, responses to the real world being sensed real time, and that we can start to see what's happening if I do this. And then you get the answer immediately, and you can start to play. Those 50 billion devices, they cover different areas. So we see the network, the cloud, the data centers. This is still there. We are still getting all our data in the cloud, in the data centers, where it's being stored, it's being analyzed. But then we see the intelligence and the processing power moving towards the edge, where we call the network edge. You see that now not every communication needs to go to the cloud. Some communication can be solved somewhere in the intermediate level, in a building gateway, for example, where you can compute already what is the best setting for getting the best energy utilization in my building. At the local servers, at the base stations. And what is now racing and what is driving the next wave of innovation and what is driving the next wave in AI is, as Fabrizio already mentioned, it's about the edge. The edge means that a lot of the computation that before was not possible to do in our devices, we couldn't have a watch that measures our temperature. That's all possible now because of this compute power. We are able to cram so many compute power in all of these small devices. The early versions of Siri were sending your voice to the cloud would analyze what you said, and then the response was coming back. Now, this is happening in your mobile phone. Before, when you needed to do some application with voice recognition, your voice was saved, was sent to the cloud, and then it was coming back. Now, all of this is happening at every small device already. And I recognize that these devices are still very limited, but for us, it is actually an opportunity. Before, it was not possible. Now it is possible. So now we can have all of this computation here. And because of that, there's a lot of things that we can do. Before I go into this, let me very fast talk about what are these machine learning algorithms and why did happen, why did they represent such an interesting thing. And of course, if you are into it, this is too high level and too probably wrong, but I think for me it's a way of explaining how things are different now. So conventionally, what we will try to do is to try to understand the world. So we will try to make models, find algorithms, find all type of models of our real world. And then this model of the real world, we will get an input. We apply that model, we apply that algorithm, and we get an output, right? So if we want to calculate, if we throw a ball, where it's going to land, we have a lot of physics that will tell us, OK, if you throw a ball here, it will land there. It's very easy. You know exactly your model, and you can apply it. Unfortunately, in the real world, many of these models are very hard, are very difficult, are not known. We don't know how to model everything precisely. And sometimes, if you see very often that it takes very long if you want to take all the corner cases. So very often, you make the models for a limited set with a set of constraints. What happens with machine learning? Well, with machine learning, it's a little bit different. You actually have your input and you have your output. And you give your input and your output, and the learning code will generate the model. You also can tell, OK, which type of neural network I want to apply, or how complicated it should be. But basically, you need to have your input and your output. We can now understand why this was not very successful in the past. How easy was it to get all your inputs and all your outputs in a digital form? Now, with the internet, I made a search for the word cat. I got 3 billion images in less than a second. So that's how fast you can get your data set in some cases. And then you can generate your model. Of course, this model now is something that we don't really understand because the machine has done it. The machine has analyzed all the inputs, has analyzed the outputs, and say, well, I see these correlations, I see these patterns, I see these relations. And when I get this input, then I can get that output. Then what do? We put the machine in the real world, in our edge device, or also in our cloud, and then we give it a new input, and then we hope that the output is correct. And of course, if the input is very different from the input that I used to train, then this will not work. And then we have to really curate the data set that we are using. That's why data is so important. That's why in the discussion previously, we were talking about data. How much data do we have available? And how much do we know about this data? Can we easily say, if I get this input, this is the output I want to get? If you look at this picture, you also can start to understand some of the difficulties as well. So if I have trained my machine, my model, with a picture of a truck always standing straight, and I give it a picture of a truck standing upside down, it will fail. If I give inputs and outputs that have been generated by humans, for example, is a clear example. If I give my machine a set of CVs and the answer of the manager of this person's being hired or not, then the machine is going to generate a model of this manager's choice. It's not the best, but it's this manager's choice. You see how bias can creep into our solutions if we don't have the right ones. You can also see that this is at this moment a model that is generated, but we also have, in many cases, we do know the solution. So AI or machine learning is not the solution for everything. If we know exactly our data, you don't need to get here. But if you don't, you can use this. And actually, the best way will be to combine. So all the things that we know, let's still use it. Let's try to bring those into the model, and then let the machine learn the parts that we don't know. So hybrid between what it was called expert systems and neural network systems. So in this case, these are the things that we know. So we knew the input and the model. Now we know the input and output, and we actually generate the model. So what is making all this possible? This makes the possibilities of machine learning and AI are limitless. So we talk about compute vision, and I think compute vision made a huge step in 2012 when suddenly someone decided to apply one of these deep neural networks to an image recognition, and suddenly got an amount of performance increase. But we can apply it to many other things that, for example, we as humans are not that great at. So we were talking about a machine, ASML, creating wafers. Of course, as NXP, we use the machines of ASML, and we get the chips back. And you see that very often there is a visual inspection that is happening. So there is someone with a lot of knowledge that is looking at the IC, and he says, OK, it seems that there is an error here. Well, people get tired, and you may oversee something. A machine doesn't, and a machine can look a lot of images, and then they can learn to recognize if there has been an error in the wafer or if there is a mistake somewhere. We see also this being applied to many other sense and control. So I'm working on innovations for automotive, and there we have the whole electrification topic. We have batteries coming in the car. We have motors coming in the car. And all of these, they have sensors, and you can learn a lot about the state of health. If you try to model all of that, it's a bit complicated and hard. If you try to use machine learning together with what you already know, you get improvements, big improvements on the performance there. I see I'm a bit under overtime, so let me say a few words about what do we do as NXP. Of course, we see all of these trends, and we want to help everyone that says, hey, my problem is not that easy to model. I would like to use machine learning, so what can I do? Of course, we're making a lot of semiconductors, a lot of microprocessors, a lot of sensors, but then we also provide the environment to be able to learn. So we have, from the preparation and data training to the validation of your model, to the deployment of your model, and making sure that this model is actually fitting to your edge device. So we are able to bring the model, prune it down, and compress it so that you can actually run it on your final device. The move to the edge was already mentioned. You can enable different properties. For example, you can have real-time analytics that you can get at your edge. You can reduce the traffic towards the data center. You can reduce the cost of your network. You can safeguard privacy. You don't need to send the image to the cloud. You can do it locally without compromising privacy. It can increase security, so your data is not going back and forth through the network. We see a lot coming to the edge. So we provide all type of compute engines, and we partner and we support all the existing frameworks for the edge and for the cloud that will allow you to deploy your solution. And let me jump to the last part, where we say we also have the Machine Learning Academy to help you, to help our partners to learn. So just to summarize, I think we are walking towards the aware edge, where we see that the edge will be secure, will be safe, and will be responsible with machine learning and AI acceleration. And we don't do it by ourselves. We do it with partners. We do it here in the region with the Eindhoven AI Institute. We do it with the AI Forum here at the campus, with the partners, universities, other companies, trying to bring this revolution and to make it a reality. Thank you.
Thank you, Clara. You already told about the Machine Learning Academy, really quick. Can you tell us a little bit more about that?
So the Machine Learning Academy is focused on how can you use the machine learning in your business. And we are talking, of course, vision, of course, voice. Those are the big ones. But we are looking into many other sensors part. So basically, if you have a problem that you want to solve, you want to use one of our microcontrollers, then you can use everything that we have there to deploy it. So from which frameworks to use, if you want to use your own framework, we also adapt. And how can you make it small? How can you prune it? How can you compress it so that it runs at the edge? Yeah.
And you told about working together with all kinds of hubs here in the region, as well as the AI Innovation Center. How is the Brainport region doing when we look at this, at AI in business, putting it into practice?
Yeah, I think there is a lot of startups. There is a lot of life. So we are trying to ride the wave. We also have to realize that this is not, let's say, the end solution, right? But this is the solution that in the coming years is going to make a big step into many of the applications that the Brainport region companies are going to use.
And if someone is listening and knowing, okay, I really want to do more with AI, what would be your giveaway?
Look at the problem first, because you need to have a lot of data, a lot of digital data. It could be annotated or non-annotated, that depends a bit. And look at your problem, whether it will be something that can really benefit from AI. And then experiment.
Okay, well, thank you so much for your time.
Yes,
thank you.
Thank you very much.
Clara Otero Pérez of NXP, thank you for joining. So I'm excited after hearing these stories, and we have 3 more exciting short stories for you, because we're going to hear some startup pitches of startups who are working with AI and ready to blow our minds. So let's hear it for Jacqueline Kazmaier, CEO and co-founder of Autoscriber.
Thank you. And yeah, good afternoon, everyone. I'm really excited to be here and to talk to you a little bit more about Autoscriber, where we are envisioning to completely reimagine patient consultations in the healthcare sector. So I'd like to start out today with a little thought experiment on what the future of healthcare might look like. I think most experts in the industry would agree that the future of healthcare is in some way or form data-driven. And for us, this means that we can support the doctor in real time during the consultation by providing a personalized recommendation for each patient. And that's based not only on what is said during the conversation, but also on a blood test that the patient took 10 years ago, on their genetic makeup, how they responded to previous treatments, and even how a similar patient in a different hospital responded to a treatment yesterday. Now, why is this something that's in the vision of the future, and why is this not something that's already happening? Well, simply we won't have the data at hand to be able to do this. In a typical consultation of today, you're spending between 15 and 60 plus minutes with your doctor. And after all of that, the entire encounter is summarized in 2 to 3 lines in the electronic patient file, which means that a lot of valuable information is lost. And this information is typically only captured in free text fields, which are very difficult to use downstream. And even though electronic patient records have innovated and have added a lot more capacity to capture fine-grained structured information, it's simply too time-consuming for doctors to do this, adding to their administrative load and taking valuable time away from patient care. At Autoscriber, we plan to reimagine this process by capturing the entire conversation between doctor and patient, transcribing the encounter, and extracting relevant clinical information such as symptoms, medications, and their properties from the conversation. We then take this information and use it to pre-populate the electronic patient file and to enrich it with structured information and a record of the conversation. This means that we now have a record of the conversation that the doctor can refer back to prepare, and that the patient can share with their loved ones when making important medical decisions. It also means that we can automate part of the administrative process for doctors, giving them time back to do what they do best, namely caring for patients. And finally, and most importantly, this allows us to create a consistent, complete, and structured repository of each patient consultation in the electronic health record, and that allows us to perform a lot more research and development downstream. So what's next for us as a company? Well, we're currently running a pilot of our software at Leiden University Medical Center, and we're looking forward to rolling out our solution in the Netherlands after this, with vision to become the trusted partner for this technology in the European Union. Thank you very much, and please do reach out to us if you have any questions.
Thank you so much. Thank you for joining. Thank you. All right, let's move on to our second pitcher, Sako Arts of Fruitpunch AI. Give him a virtual applause, please. Welcome on stage.
Thank you, Ingelou, for the introductions. Some of you guys may expect Buster here. He's also very pretty, but I hope you'll do with me today. Let me first introduce our company. We as Fruitpunch AI are the global AI for good community. But what does that mean? Well, we teach and apply AI for good. But let's start with the problem. So the problem that we all experience actually is that there are a grave lack of good AI engineers. And that's not only something that's playing out now, it's only going to get worse if you believe the quote down here that many of you must have heard. Every company in the future will be an AI company. But not only are there not enough engineers, they only don't get teach AI in the right way. They get teach the very theoretical parts, but fail to learn AI in practice, which is actually something that is 85% of an AI engineer's work these days. And then in the end, it's very risky for companies like maybe yours to even innovate with AI and try it out, since you need expensive AI engineers, large teams, and you don't know what the results are going to be. So we hope to change that. Our vision is if we want to change humanity's greatest challenges, we need to educate AI engineers at scale, and we need to redefine how we solve these problems. So how are we going to do this? Well, of course, through a mechanism of challenge-based learning and peer-to-peer learning. So what we do is we organize AI for good challenges. We collect those challenges from organizations all around the world, NGOs, impact startups, but maybe your company soon in the future, and we define a problem where we can use data to solve one of the problems that works towards the Sustainable Development Goals, so works towards good. If we find such a challenge, we use our community, crowdsource people from our community to solve this problem in a collaborative AI for Good challenge. And we have already organized over 20 of these challenges and have over 1,500 AI for Good engineers in our community. So how does such an AI for Good challenge look? Well, we crowdsource about 25 to 50 people in such a challenge, and we build a prototype in about 10 weeks. In the meantime and beforehand, we of course do a lot of promotion to connect you and your company to our AI for Good message and to our movement. A few examples of that would be the AI for Wildlife Challenge. This is actually why Buster is not here, because he's currently in South Africa saving the rhinos as I'm speaking. But what we're doing there is building an autonomous drone that searches for poachers in the nights above the wildlife reserves in South Africa. So automated poacher detection and automated drone flying. Furthermore, we've built an algorithm that is able to segment lungs out of X-ray images, saving doctors large amounts of time. We use that generative adversarial network for that, for the AI nerds in the audience. And this is currently actually being implemented into the Maastricht University Medical Research Center. And then lastly, for the examples, we have the AI for Earth challenge, where we collaborated with ESA to find the human impact on the Earth using satellite images. So think about forest fires, deforestation, coral bleaching, all these types of challenges that we make the Earth face, we can also detect on these satellite images using AI and by crowdsourcing those from our community. So what do we need to organize such a challenge? Well, firstly, a problem, of course, of which the solution works towards the Sustainable Development Goals, but also data. We can't pluck data out of the air, sadly enough. So you and your company need to provide that. But together we will formulate a solution, and then we will crowdsource this team. Furthermore, we need active participation from the stakeholder here. Not only because you are then able to steer the team in the right direction, but also because this is a very important learning aspect for the people that are in the challenge, which is for them the end goal. Learn how to do AI in practice. And there the stakeholder management, giving presentations is all a very important part of this. And lastly, communications. Growing this community, we can't do that alone. So there we need partners to also communicate our AI for good message. So when you organize a challenge together with us, you'll also better be communicating about our mission together. Then lastly, where I want to get in shortly, are AI for Good labs. And these are actually strategic collaborations between many different companies, so consultancy companies, but also the NGOs who are having their hands in the dirt to solve one of the SDGs. And we collaborate and organize multiple of these challenges within this AI for Good lab. And currently, we're actually in the talks with the AI Innovation Center here at the HCC to start such a lab, and we're looking for partners for that. So I actually have a call of action to end on. Become partner of our AI for Good HCC lab. We love to hear from you. Just reach out and we can collaboratively organize multiple challenges into a specific team. Furthermore, if you already have a challenge laying around, contact us directly, leverage our community, and make sure that we organize an AI for Good challenge together. And lastly, for the AI people in the audience, educate yourself. Learn more about different types of state-of-the-art technologies and become part of our community by joining our community platform on our website. Thanks you all for listening and have a very fruitful day.
Thank you. Thank you so much. Thank you for joining us. Thank you. All right, a fruitful day. I'm almost going to wish you that as well, but we have one more speaker left. So give her a big virtual applause because last but not least, Benedicte Lochtenberg, CCO of Scalable.
Thank you very much. Yes, and I'll try to explain to you in 3 minutes how you can benefit from artificial intelligence on the edge. So I'm going to talk a little bit more about the applications. And while Fabrizio and Carla, they talk more about the hardware, I will talk more about the software and the models. So, as I said, and my name is Benedicte Lochtenberg, as I was just introduced, and I'm CCO and shareholder of Scalable. Now let's explain our added value with the help of an example. Now this is the event booth of Advantech 2 months ago at the Vision Summit in Stuttgart. And they want to improve the efficiency of their events and start with AI on the edge. So first they wanted to count people at their event, and they thought, okay, let's make some pictures of people, send it to the cloud, get it back, calculate the number of people, and then send the results back to the booth. However, internet connection at these events is really limited, so that was not the right solution. So they thought, okay, let's get the algorithm to run on this simple gateway. And that's how we helped them, because we had let's skip this. We helped them to get it on this machine. But getting an algorithm on this limited device is quite difficult, especially because the capacity is really limited. And also to deploy your model that you trained in the cloud, to get it on this device is quite difficult. But that's why we developed the Scalable AI Manager. And with the AI Manager, you can easily pick an artificial intelligence model from our library and get it going on this device. And all you have to do is attach a few cameras, and then you're ready to go. Or as Fabrizio said, plug and play AI. Now, if you want to innovate and improve your model, then still you want to have a method to get the model from the cloud on the device. And instead of optimizing the hardware and increasing the capacity of the hardware, we have found a solution to optimize the model and shrink the model so you can fit a more complex model on the same device. And that's how we're helping people to get AI models on whichever edge device you like, whether it's a cobot, a robot, or a gateway like this one. And maybe we should also collaborate with Accelera and NXP. We are talking to them at the moment. Yes, and I have a few examples of how people are benefiting from our technology at the moment. Just to give you a few examples. This is a company that's producing mushrooms, and they're checking with cameras if the basket is full or not with mushrooms. Saves a lot of labor. We help Sappi, a paper factory in Germany, to predict maintenance, to cut down on their downtime. We are helping a company to improve their logistics just by simply knowing exactly at what time the lorry is arriving. And we help people to improve their safety by giving an alarm when people are getting too close to a danger zone. We're also helping a company to distinguish between the good and the bad products by adding a camera to a cobot. And we're helping supermarkets to do some retail analytics so they can replenish the goods at time. And we could even, we're not doing this yet, but maybe we should start doing this, checking if people are keeping their distance. So I'm really wondering if there are people listening that are also have some business cases where Edge AI can really be beneficial to them. And if so, just reach out to me. You can easily find me. There's not many people that are with the same name, Benedicte Lochtenberg. So hope to talk to you soon. Goodbye.
Thank you.
0 seconds.
Perfect. Thank you. All right. So this was it, the Back to Business AI edition, the first edition of Back to Business, hopefully next year in real life, also hopefully in a few months. So if you want to know more about the AI Innovation Center, find us on social media or visit the website hightechcampus.com/AI. If you want to work together, visit, or maybe even come here with your startup or company, let us know. For the next event for Back to Business at the High Tech Campus, follow us on social media. We're very easy to find at High Tech Campus. And for now, I wish you a fruitful day. Thank you.